Hi students, welcome to the session on basic properties of charge. I am Sheikh Majeeth. In this session we are going to see about basic charge, law of conservation of charge and quantization of charges. The first property is electric charge. We all know that objects are made up of atoms. Atoms are made up of protons, electrons and neutrons. These particles possess mass. Mass is an inherent property of these particles. Like that, these particles also possess another inherent property that is known as charge. Inherent property is nothing but natural property. They have naturally possess mass, they have naturally possess charge also. The basic unit of the SI unit of charge is coulomb. That you must remember. It's very important point. The second property is law of conservation of charge. We all know that Greeks have rubbed amber, Greeks used amber rubbed against animal fur, and they found that that amber attracted leaves and all, right? So the more experiments have been conducted in a day, year after year, and Benjamin Franklin has found that when two objects are rubbed against each other, charges get transferred from one object to another object, right? For example, when we rub a glass rod against silk, what happens is that the negative charge in the glass rod transferred to silk. So some object which is losing electric charge, negative charge will become positively charged. That we know, right? Similarly, those objects which accepted that charge will become negatively charged. So glass rod became positively charged and silk became negatively charged. This led to the conclusion that charges can neither be created nor be destroyed, and they can be only transferred from one object to another object. That means total amount of charges in the universe remains constant. You cannot increase or decrease. That's what you cannot, you can neither create or nor destroy. So this is what Benjamin Franklin concluded, that became law of conservation of energy. As per his conclusion, the total electric charge in the universe is constant and the charge can neither be created nor be destroyed. Right? So in any physical process, the net change in the charge will always be zero. Why net change is zero? Because I am not creating extra one or I am not destroying what is already existing. So net change is zero. This is what law of conservation of charge. It is similar to law of conservation of energy that we know already. What law of conservation of energy says? Energy can neither be created nor be destroyed. Similarly, law of conservation of charge says charge can neither be created nor be destroyed. That's it. It's a second property of charge. Third one is charge quantization. What is charge quantization? Why should we know about that? Before studying this somewhat critical concept, I give one example, then you will understand charge quantization very easily. So let us take one line, right? So it's appearing like a continuous structure, but actually line is made up of infinite number of points. Yes or no? We have known this from mathematics. If you connect infinite number of points, that will become line. Yes or no? I put a lot of point. If you connect all the things, it will become a line. So what is the relation between line and point? Line has infinite of points, infinite number of points. So what is point? Point is nothing but the smallest line exists in the world. Yes or no? So point is the smallest line. So what can I conclude from this? Point is the smallest line exists in the world, or point is the fundamental unit of line. Fundamental unit means which is the smallest one, right? For any number, 1 is the smallest number because any number can be expressed in terms of 1. Like that, any line can be represented in terms of point. So what is the basic or smallest, that is called fundamental unit. For line, point is a fundamental unit. So how can I suppose my line has 1 billion points. This is a small line, it may contain 1 billion. If you draw the big line of 100 kilometers, that may contain that much of points. So point has, sorry, line is equal to n into p. N is a number of points, p is a 1 point. Yes or no? So line can be expressed in terms of number of points into fundamental point p. Yes or no? If suppose my line has 1000 points, so I can write L is equal to 1000 into p, 1000 p. Yes or no? Because it is made up of 1000 points, so I write as 1000 p. If it is made up of 2000 points, I can write 2000 into point. If it is made up of 10,000, like that I do. So this is what, yeah, example. Now compare this analogy with our problem. You see that now people know about charge. Then they asked the question, what is the smallest amount of charge exist in the world? Then this question was asked by many scientists. Then they concluded that all the charges can be expressed as an integral multiple of fundamental unit of charge E. This is what they have found after doing so many experiments. That means all the charges, so any charge Q can be expressed as integral multiple of fundamental unit of charge E. E is a fundamental unit of charge. Fundamental unit of charge means the smallest amount of charge. N is an integer. It may vary from minus infinity to plus infinity. It may take any value, right? So they asked what is the smallest unit of charge. Then they concluded through experiments the charge on the electron is minus E and charge on the proton is plus E. This they found by after doing so many experiments by so many scientists. So charge on electron is plus E, sorry, minus E, charge on proton is plus E. Clear? So the E is a fundamental unit of charge. Then what is the value of this E? That has been found by Robert Millikan in 1912, and he found that the E value of electron is minus 1.602 into 10 power minus 19 coulomb, and the E value of proton is plus 1.602 into 10 power minus 19 coulomb. That means what? Both electron and proton carry same amount of charge but opposite sign. Proton is positive 1.602, electron is negative 1.602, right? So what is that? Now they found fundamental unit. So I told fundamental point, any line can be expressed in terms of fundamental unit of point, right? Similarly, any charge I can represent as a Q is equal to plus or minus Ne, plus for proton, minus for electron. Clear? So when we have to use this concept, whenever you are using finite number, it is becoming a discrete. Continuous means it is infinite number, right? So this, whenever we are talking in terms of fundamental unit, the charge is considered as a discrete packet. So this concept can be used only when we see or analyze the charges in microscopic level. That means when we analyze in depth, even at the smallest level, then only we have to use this charge quantization. If you are going to analyze charges in an overall big way, that is macroscopic way, then we don't need this charge quantization concept, right? So charge quantization, for example, if you talk about 1 electron, 10 electron or 20 electron, you can talk about discrete packet, that is charge quantization. Q is equal to plus or minus Ne. But if you take your mobile phone, it has billions and billions of atoms and charges. There it is a continuous. There you don't need to apply charge quantization. But you want to talk about only one electron in your mobile phone, because your mobile phone is object, it is made up of atoms. That atom has electrons and protons. So if you want to do analyze that electron, you need charge quantization. If you want to think about your mobile phone, we don't need. That is a big picture, big macroscope. Macro means big, micro means small. So microscopic analysis go for charge quantization. For macroscopic analysis, no need to go for charge quantization, right? And another thing we have to note is the mass. Mass is not found by Robert Millikan. Please remember, Robert Millikan has found only E value. So mass of a proton is 1.6 into 10 power minus 27. Mass of electron is 9.11 into 10 power minus 31. You see the difference? The proton has more weight because it is 10 power minus 27, electron is minus 31. So compare these two value. It is, but if we compare these two, then we understand that mass of proton is 2000 times greater than mass of electrons. So proton is so bulky, whereas electron is so small. So it is 2000 times bigger. This concept we will use when we study about electricity, right? So that's all about this session. I have put some questions to test your understanding of this session. Please submit your answers in the comment section. Also, if you have any doubt, you can ask me in comment section. I am happy to solve and clear all your doubts. Thank you.